Hello everyone, welcome back to my channel. So in my previous video, we had seen how to assign IP addresses on Cisco routers. Today in this video, we are going to see how to implement static routing. So first of all, let us discuss what is static routing. The word static itself explains that it is going to be a manual process. So in static routing, the best path is configured manually by the administrator. To configure the best route or to know about the destination, the administrator needs to have the complete knowledge about the topology, which means that the administrator should have the information about all the possible routes available to reach a specific destination so that he can select the best route and place it in the routing table. Now, it is also considered to be secure and fast. It is secure because it is the administrator's choice whether he has to configure the route or no. The router is not going to learn about the destination by itself via updates from the other routers. And since there are no updates exchanged, the bandwidth consumption is less, and it also reduces the resource consumption as the administrator has pre-configured the route into the routing table. There are a few disadvantages to static routing. The first disadvantage is that everything is to be configured manually by the administrator. The second disadvantage is that it is only implemented in small networks, as if you see static routing, the administrator has to manually configure the routing table, which means that the administrator is going to build the entire routing table. And if you increase the number of networks and if you increase the number of routers in the topology, then the number of IP route statements will increase. It is going to increase the administrator's work. And the third disadvantage is that whenever there is a change in the topology, the administrator has to go and update the routing table manually. So right now in this topology, as you can see, I've already configured the IP addresses. So to check the IP addresses, I will run the command show IP interface brief, pipe exclude the unassigned ones. So exclude the unassigned IP addresses. So you can see here the IP addresses on Ethernet 0/0 is 1001 and Ethernet 0/1 is 192.168.1.1. So if I say show IP route on router 1, you will only be able to see the directly connected networks. So here you can see we have 1000/30, which is a directly connected network on Ethernet 0/0, and we've got 192.168.1.0/24, which is also a directly connected network on Ethernet 0/1. So currently router 1 does not have any information about 192.168.2.0/24 network, which is on router 2. So basically we have to configure a static route, and as I said, we will enter the global configuration mode first. I would say config t IP route. So I have to first provide the destination network ID. So in this case, my destination network ID would be 192.168.2.0. My destination subnet mask value will be 255.255.255.0, and I can either provide my exit interface, which is Ethernet 0/0, or I can provide the next hop IP address. Now it is recommended to provide the next hop IP address, so I will be providing my next hop IP address, which is 1002. So that's it. So the static route has been configured. Now I'll exit back and say show IP route static. So when I say show IP route static, only the static route will be visible. So as you can see here, I've got my static route. So now router 1 knows how to reach the destination. But before I send any ping messages, what I'll do is I'll go back and I'll configure router 2 also, because without configuring router 2, you cannot go ahead. You cannot verify the communication, because the package will be sent, but there will be no reply coming back from router 2 if you don't have a static route in the routing table of router 2. So whenever you're doing the verification, make sure that you configure both the routers first, and then after that you do the verification. Only by configuring router 1 you will not be able to reach the destination, or you will not be getting a reply from the destination. So let us go and configure router 2. So here I would say again IP route. This time my destination network ID is 192.168.1.0. My destination subnet mask value is 255.255.255.0, and my next hop IP address would be 1001. So that's it. I've configured this. Now if I say show IP route static, show IP route static, so you can see a static route is placed. Now I can go to my PC, one of my PCs, Right now if I say show IP, I don't have the IP addresses, so I'll assign the IP 192.168.1.2/24, and my subnet mask value is /24 here. My gateway is 192.168.1.1. so it is checking for a duplicate address. This IP is not in use, so my device has successfully got this IP. Now let me go back to PC4, which is a PC connected on this subnet, which is 2.0. so I will assign IP 192.168.2.2/24 again. 192.168.2.1 is the gateway, so it is also checking for a duplicate address again. Okay, so the IP is successfully received by the PC. So let us go to PC1 and try to ping PC4. so I would say ping 192.168.2.2. so I'm trying to reach PC4 from PC1. Okay, so when I press enter, as you can see, we are getting successful replies from PC4. So let us go back to PC4 and ping 192.168.1.2, and yes, we have a successful reply. So this is how you can configure static routing. Now the same scenario can be implemented, like let's say if you have 5 router topology, or if you have more than 5 routers, which is actually not recommended. It is not recommended to implement static routing in a topology where you have many routers, because you have to manually configure the IP routes into the routing table. So this is how you can implement static routing. Now the commands will be the same even if you have more than 2 routers in your topology. It is just that the number of IP route statements will increase. I hope this video has been informative for you, and I would like to thank you for viewing.